And what I'm doing here today is really introducing, previewing, if you will, a book that is the result of all that research that we did. And that began in 2016. So it's been a lot of people have been involved. And here we go. Okay. So here's just a very kind of the preview, at least of the way the book is shaped. So it was built around the answering various critical research questions. What are the essential characteristics of target value delivery? I'll just call it TVD from now on, if that's okay. How are project value and the corresponding cost targets set? And I'm showing the chapter numbers where these are addressed. How are projects steered toward value and cost targets? What's the history of TVD's development? Where did it come from? And that's an interesting, there are some findings there that are new, for sure. Has TVD demonstrated success in setting and steering to value cost targets? What estimating methods and tools are used in TVD? How is uncertainty managed in TVD? How is TVD used in practice? Excuse me. And this section has, I believe, five cases, if you will, each of them by a different practitioner of TVD. So there's one from, there's an owner, there's an architectural engineering firm, there's a cost consultancy, and then there are two general contractors, different general contractors. And each of them come at it in a slightly different way because they play different roles in projects, right? But so we're trying to give you that kind level of information, level of detail, so you can really better match your practice to the best practice. And then what is the relationship between TVD and Lean? And for a Lean Construction Institute, that's a pretty important question. Okay, 8 chapters written by a total of 22 authors, right? So here goes. So how to set value and cost targets. A key presupposition of TVD, I'm just reading here, is that target value can be set prior to design based on the objectives for the project. That's value targets are what are needed for achieving those objectives. Right? A second key presupposition is that an allowable cost can be set based on expected benefits from hitting value targets. Right? And I'm so accustomed to this, it seems just plain as it's very obvious that these are true and reachable. But I can understand that it's in some ways very different from normal practice. Oops, sorry. Okay, and so we start in this one. Oh, it didn't do. Okay. So the first step is to develop a functional program based upon project objectives. It's really from the voice of the customer and all the customer stakeholders, right? Now, there are other customers, other stakeholders and projects, and target value is relevant for them too, but this book focuses really on the perspective of the owner as the business venture that projects are. Right? So you can see that functional program includes these 4 elements: functional outcomes, qualitative requirements, and then you also have to pay attention to external conditions affecting the project and the issues of irreducible uncertainty. There's always, for every project, except the very most simple, and perhaps then we're even can be surprised, there's some elements of that information, events of the future, right, that we can't fully predict and control. And so we have to try to at least estimate how much how much that's going to be a problem for the project, right? And then use compensating maneuvers in order to deal with it. So I'm gonna I'm not gonna try. This is going to be a chewy kind of dense presentation because it's for a 300-page book, something like that, and even an hour is going to be tight. So in many cases, as here, I'm going to leave you the slides, and when you see the slides, be sure to look at the notes underneath them. And I don't know what that function is in PCs, but in Mac and Apple products, it's called Notes Page View. But just to look at the first two here. So quantitative performance statements, that's examples of functional outcomes. What do you want to build? What do you want to do with the building, right? How do you want it to perform? And you might specify that in the case of something where, like a factory or a hospital, in the number of procedures to be performed, maximum response time even, let's say for emergency services. And so all of those kind of performance characteristics, right? And then some qualitative requirements are typically relevant. For example, 100% uptime, right? If it's a productive facility, achieves LEED Gold, which is a measurement of its degree of sustainability, impact on the environment, and so forth. Okay. So then, and this is a decisive piece, because this is what allows you, excuse me, pardon me 1 minute. This is what allows us to set value and cost targets prior to design. Okay. And I suspect that normal practice is more often built around the assumption that you don't really know what it's going to cost until you design it. Right? That's not necessarily true. Right? So what happens here is, a type of regressive thinking. I think we do it all the time. It's common. It's the way design of anything proceeds. Is you're trying to produce something that has certain characteristics, capabilities, right? And you want to regress, think backwards to what provides that functionality, right? And that's called regressive thinking. All right. And so here are some characteristics of that facility program. Spatial, these are not, we didn't make these up, these are out there in the world, right? A space program, so what spaces and the functions for those different spaces, and then all the characteristics of those spaces that enable and support the functions. Qualitative requirements again, acoustics, lighting, airflow, right? And these are often captured in buildings and room data sheets. And then external conditions and irreducible uncertainty again, but now relevant to the facilities program as opposed to the functional program. So now, this is to the point that TVD involves setting value and cost targets prior to design, right? So in the quote, this is a quote from chapter 2 of the book. It is important to note that the facility program is still design independent. While there may be sketches or massing diagrams to support the concepts and quantification of the facility program, they are not intended to be design solutions. They're tools to bridge and assist our understanding in getting to design solutions, right? Specifying for design what's to be designed within what cost. Okay. Okay, now here is an example, and this is from our research. This is a company called Hatala Group. They're based in Helsinki, Finland. And And I'll return to this in a little bit more detail later, but in 1980, Irjana Hattala, who was a professor at the university in Helsinki, was also working in the government building group or economics group, if you will. And he had the challenge of coming up with a way of setting costs for building. Sorry? I guess that was someone with their mic not muted. Okay. So, and let me just show you the words. So this is a quote from chapter 3, I believe. What's wanted, target values, and the cost of providing what's wanted, target cost, are determined prior to design by creating through simulation a model of a building from the voice of the customer, then costing the model materials, components, and services needed to construct that building. Okay. So that's reasoning backwards. In this case, using simulation, we found that there were two primary ways to do that, tools to support that regressive thinking from desired functionalities to what provides those functionalities. And in this case, with Hattala, they've developed a computer program. I think it's got over 500,000 lines of code in their current version of it. It's in their 5th version since a few years ago. And but it's like a building information model, right? Except you don't have a graphic readout because you don't want to, because what you're trying to do is not to complete the job of design, but rather to establish an amount of money that is sufficient to deliver the desired functionalities. Okay? And if you will have questions, please note them down, and I hope I get a chance to speak to them. Okay, now this is really critical. The simulation model is fully detailed, buildable, and capable of supporting the desired functions at desired capacities, but is not what will be constructed, leaving designers free to create designs that deliver target values within the target cost, and perhaps even to increase value and or to reduce cost. Okay. So just to follow this little diagram to make sure that we're on the same page. So this is obviously high level. It's not, there's many issues of detail in this process. It's a complicated one. Not complicated, but it has lots of parts. So the first thing to do is to understand, what are project objectives? What are you trying to do? What do you hope to accomplish? All right. Let me get this in here. Sorry. I have crib sheets here and I'm trying to remember what's on them. Okay. So then the next question is, what are we willing to pay to achieve those objectives? So this is a question that the client company, the owner of the project, are saying back and forth to themselves, perhaps with that guide, the assistance of a facilitator. Hattala provides that facilitation, for example. What are we willing to pay to achieve those objectives? And then what are we able to pay? So we might be willing, but not able. Right? And so you have to, but those two together constitute the allowable cost for the project. Right? And then, of course, you want to see, well, that may be what we are willing and able to pay, but will it be enough? Right. So how much will it cost? Right? And we've talked about that, and that's moving from the functional program to the facilities program and costing the facilities program, right? Costing that model. So that costing of the services and the components of that facility program give you the expected cost, right? And so then there's a kind of dialogue between expected and allowable, right? And it may affect what you are expecting to get out of the project. It depends on how it goes, right? So if the expected cost is less than allowable, then you're in good shape, right? If it isn't, then, so let's just follow the arrows down. So EC less than AC, yes. If it's yes, you might even consider adding some to your value targets, right? Because you have enough money to get them, right? And if you do that, then you have to go back through in order to make sure that you're not messing yourself up. You still want to have a viable project. If it goes out of that diamond, EC less than AC, and no, then the question is it feasible? And there's some various ways of determining that, but basically you do it in, I'll talk about this in just a second. I think the next slide. You do it through a combination of, basically through an operations plan for the project execution plan. And in that plan, you identify uncertainties, risks, and methods for mitigating those risks. Right? Now, if after all that is done, you say, well, is it feasible? There's the residual risk that I'm willing to bear in order to get what I want for the amount of money that I'm prepared to spend? If it's definitely not, then you either change objectives or stop the project. And I think if we followed this kind of simple discipline in project definition for our projects, we would avoid doing a lot more bad projects and get a lot more good projects. So if it is considered feasible, then you validate the business case. So let's look at that. So first, just to step back just a little bit. So there are several different types of target cost, and you really have to be careful about which one you're setting. As is common, you may say, well, I have a maximum amount of money I'm willing and able to spend, right? So that would be your target. There's another way of doing it, saying, well, how close can I get to a target? So like a bullseye and a target range, right? And then there's also a form of of target cost that's called a stretch goal or stretch target that you deliberately set below what has previously been achieved, right? And thus requiring either better execution and or invention, innovative design, right? So innovative construction methods too. So, and that of course is one of the fundamental principles of Lean is continuous improvement, and setting stretch goals is essential in that process. Okay, there's a target value statement that covers everything that it's a total statement about what are you trying to get out of the project, right? What do you have to hit in order to consider the project to be successful? And then the project execution plan is an articulation of how the team plans to deliver to target: organization, schedule, risk mitigation, all of those things. And there's, in the world of integrated project delivery projects, that form of project delivery, there's reports published about how they manage that validation, right? So, so Okay, then we're moving, we're sneaking into the issue of how do you steer the project, manage the project to hit the targets, right? So far I've just talked about how do we set the targets, right? But then we're going to move now into how do you steer to them. And one of the tools that's used there is a cost plan. And a cost plan provisionally allocates, and I'll explain why provisionally, allocates the estimated cost, now the target cost, elements of that target cost to different parts of the facility and the teams responsible for those parts of the facility design and then construction, right? Okay, I'm going to quote again, since this is a preview of the book, it deserves to be present in the presentation. So, excuse me, in TVD current best practice, once targets are set, multiple alternatives or for building systems and components are generated using set-based design, following that design methodology. And I'll explain that in a second. Then evaluated against factors relevant for differentiating them using choosing by advantages. And that's a method of decision-making that I will also explain in just a moment. The total importance of advantages of each are determined, then evaluated against their cost. If none of the alternatives is found to deliver their part of target value, design's job is not yet done, regardless of cost. Doesn't matter how cheap it is if it isn't what you want, right? If target value is achieved, but at greater than target cost, design is still not done. Designers continue striving for ways to achieve target values at lower cost using a variety of methods that I'm just capsulating as value engineering, right? So let's see. Okay, first I'm going to talk about set-based design, then choosing by advantages, then value engineering. Okay, because those are the main tools that are used within target value delivery to steer to targets. So this distinction between point-based and set-based design. So to simplify, it's quite common that a project will start in the design phase. They will start with a solution, if you will, a possible solution, less detailed, and then gradually more and more granular. Right, but they're doing it in I think the ungracious way to describe it is that you're making a guess. Right? And if you guess wrong, and you probably will guess wrong, to the extent that you don't have an effective way of engaging all members of the team, including all the different client stakeholders, right? For the different, if you're building a hospital, for example, or a school, there's a number of different stakeholders whose voice needs to be taken into account, right? And so very often would you start with a single solution and then try to modify it as obstacles are encountered, you very often fail to some degree. And you tend to increase cost because you have a much more rework than you could if you did a different way. And you tend to use up time in your schedule, and that tends to cause problems in design, and then they get relayed into construction. And you can even, for want of time and money, wind up with a building or some other type of constructed product that is not what you want, right? It is not fit for purpose. So to avoid that, and this idea of using a set-based approach really came out of lean manufacturing, but in the product development form or phase of lean manufacturing, not factory production, but rather the design of products, right? And and as you wouldn't be surprised, Toyota was one of the big exponents of that. So the idea of set-based design is for every design decision, you generate multiple alternatives. That may seem like it's just spending unnecessary money, but in fact, it turns out to be cheaper, faster, and better. Okay. And the very first publication on that score that I'm aware of at any rate was called The Machine That Changed the World, published in 1990. So, so with generating these multiple alternatives, this is in design, it forces designers to really think about carefully and objectively, do we have a way to deliver what's wanted? And can we find better ways to deliver what's wanted? Okay. And so it's a systematic way to promote innovation. And that's, of course, very important the more complex and challenging the project is. Now, choosing by advantages didn't come out of Toyota, it didn't come out of construction or manufacturing or operations at all. It was developed by a guy in the United States Forest Service. And so it's not peculiar to any kind of decision-making. It's general for all types of decision-making when you're looking to evaluate and select from alternative solutions, alternative directions to go, right? So I'm going to just give you a thumbnail sketch of it. So the first thing to do is, first thing is actually to generate the alternatives using set-based design. And then once you've had those, you've got them produced, you've decided, okay, now we've got pretty much everything we can think of on the table, right? Different, say, structural designs for a building, right? We define the factors that are relevant to evaluating them. And I'll just use a very simple example, say acoustics, insulation, and a wall construction, right? So we want to have, so that with noise, absorption would be clearly a factor, right? Then define must and won't have criteria for each factor. So from factor to criteria, right? So, and there are two different types of criteria. Must have criteria, that is must have in order to deliver to achieve value targets, right? And like to have preferences. And so an example from the acoustics, the door acoustic insulation would be to set a noise level, right? Decibel level for transmission under certain circumstances that are specified. And then with a preference, let's say for lower transmission, right? Better insulation. Right? Okay. Then the fourth one is to determine the attributes of each alternative. So you've got designs for wall panels, and you look at every factor, noise, let's say rigidity might be an issue, and load-bearing capability, and so forth. And you essentially come to an agreement from all the different decision makers, an agreement about, not about whether this is good or bad, but to what extent does it meet requirements, right? Okay. And then, so you haven't even talked about, you haven't evaluated yet. This is describing. Right? But then the next piece does move you in the next step, step 5, moves into evaluation. You decide the advantages of each alternative. And that's at first of all, this is the first step towards evaluation is further description, but it's relative one to another, right? So the advantage of this alternative 2 might have an advantage over alternative 3 in noise insulation, but not in load bearing capability, right? Just to make something up, right? Then decide the importance of each advantage. And when we say decide, we mean we're looking for consensus among all the people that have a stake in the design phase and the design of the product, right? And then 7, evaluate the total importance of advantages of each alternative against its cost. So we haven't looked at cost until we understand what we're costing, what we're getting, right? And that allows us to select the alternative that offers the best value for money. Right? So I recommend it highly. This applies in every type of decision making. Key features of choosing by advantages, CBA. Factors are not weighted, and that's against the grain of common practice. Evaluation is deferred until there is agreement about how each alternative satisfies requirements, that is, meets criteria. Cost is deferred until the advantages offered by each alternative can be assessed. Okay. Okay, I'm not going to go into this, just to show you that there's, this is at least one tool used in value engineering, function analysis system technique, where you're trying to look at functions to be provided by a product or some portions of a product and their relationship one to another. So this is and this would be, so why is moving to the left? Why are you doing this, right? And how moves, answering how moves to the right. Right? How do we do this? And I'll even provide a small example that I leave it to you to enjoy. Okay, so one thing, then value engineering is really about applying reasoning, all right? And there are different methods used, but what's underlying here are the fundamental types of reasoning. And there are basically 4 types. I think we're all familiar with deduction and induction. So deduction, we draw a conclusion from accepted premises. Induction, we determine the property of a class of objects from samples. Right? But in design, regression and deduction and induction certainly occur, but the big game is played in the regression and abduction. So regression is what we talked about in moving from the functional program to the facilities program, right? What provides functionality that's desired in the building. And abduction is really tightly related to regression. I'll give you an example from learning from breakdowns, right? Let's say we're we could even say in the last planner system, when we fail to keep a promise, a commitment to perform a task to a certain specification within a certain time, right? Then ideally, we go back and we try to figure out, well, what went wrong, right? So we're trying to swim, trying to find the root causes, if you will, of that mistake, that error, right? That outcome. And then, but we're not just interested in that, we're interested in doing that in order to figure out how to avoid recurrence. So we develop countermeasures, right? And in developing countermeasures, it's just like the design problem, right? We're developing countermeasures that we need to test, right? And we might develop multiple possible countermeasures, and evaluate them using CBA. And maybe incorporate in that CBA information from actual tests, right? Where we test a product design, or we test a process, many mistakes and many failures in the planning and control in the last planner world occur because we don't do a good job of following the reliable promising process, right? And so the question would be, how do we, did the process fail, or did execution of the process fail? And whichever way that goes, that fork, we have to find countermeasures for it, right? So, so when we develop countermeasures and alternative designs, we first, I think, kind of naturally go through an inventory of a search. We're trying to find, well, what existing solutions exist and which of them work best for our situation, right? Now, the challenge here and the reason that abduction plays a role at all in steering to value and cost targets is when we don't, all known solutions aren't adequate, okay? Then you have to invent new ones. And abduction is the type of reasoning that we call creativity, generation, innovation, right? And so these three different elements all work together: set-based design, choosing by advantages, and value engineering, right? So essentially regression and abduction. Okay, conditions that promote creativity, abduction. Clear goals, innovation is valued, sufficient time is provided, okay? Autonomy in how to achieve goals. So you're not trying to say, well, do this one or do that one. You're giving people the responsibility to develop, test, right? So they have autonomy. And collaboration and discussion. And I think you heard from Dr. Koskela recently, and we wrote a paper about that you can find in the International Group for Lean Construction papers. If you don't know the abbreviation, the IGLC, International Group for Lean Construction, they've produced papers since 1993 in annual conferences. There's thousands of papers, and all of them are available free at iglc.net. So take advantage. You can search it for topic, for author, and so forth. Okay. Now I want to go look at the question, how is design organized on TVD projects? And this is a really critical issue, right? So the advice is to organize in multifunctional, cross-functional teams for the different parts of the building, systems, aspects of the building that are going to be designed. And like here, we have mechanical, electrical, plumbing, structures, site improvements, landscape, material handling, vertical transportation, interior finishes, and building envelope. There could be more, or in some cases, maybe less. But I'll show you an example. I know this is a little difficult to read, but you can see on the top are the names of the innovation teams: site and civil, shell and core, fit out, and so on, right? And then leader and co-lead, color coded by the company that they belong to, right? And then coaches, in this case, and then this is courtesy of the Boat Company, is a long time and very progressive lean company, general contractor in the United States. So, and then team members, again, color coded. So you can see that there's a wide distribution of, I think we can say, I think I took site civil. Site civil is led by, I think, I can't see the side. Hang on a second. Okay, I think that's the leader of site civil is green, and I think that, can't see the color code, but I think that's the owner. The co-lead is from the architect. The team members are from the structural engineering, architect. I think this is the MEP engineer, mechanical engineer, and so forth. So, so having them, and at the bottom, there's an estimator supporting each team, some of them supporting more than one team, right? Because rapid estimating is really beneficial in steering design. So you don't have to wait forever. You produce something, and then you want to know, well, how would this design be cost? What would it cost? And if you have to wait for a day rather than 10 minutes, then it makes a huge difference. And this is an example. It's a template for innovation teams participating in the last planner system, right? So you can see that all of the functions are performed, and this doesn't include, obviously this doesn't include the weekly tasks themselves, but they would be added. And in this case, they co-locate Tuesday and Wednesday every 2 weeks and produce a 2-week work plan for design. I think I'm getting close. I've got about 10 minutes, I think. So tell me if I'm wrong. Okay, steering to value and cost targets in construction. This is courtesy of Sutter Health, which is a large regional healthcare company in Northern California, the largest in Northern California. And this is from a recently completed hospital project, $1.5 billion in downtown San Francisco. And I use it to show that the value targets can have a wide range, right? And it's been said, and I've been one of them, that lean is the best philosophy and framework for achieving the triple bottom line of sustainability: economic, social, and environmental. Right? And their goals in here, the first at the top, safety, people-related goals, for example, promoting employment within the local area, project team use of alternative transportation, right? So what they're doing, so the first one is pretty clearly social, although accidents have costs. So there's a link there to economic. Using public transportation as opposed to many more cars on the road. That's environmental, and so forth. So you can't. Some years ago, someone developed they changed the term from target costing to target value design, and for a very good reason, that because value is the driver, not cost, right? Doesn't matter what it costs if it's not good, it's not what you want. But I've changed it to target value delivery because you haven't delivered value to the customer until you've built it and commissioned it and handed it over. Right? So we have to continue steering to value and cost targets through the end of the project. It's not just in design. And here, I'll leave this to you to look at. Quickly, history of TVD. So I'm sure we haven't found everything, but we were able to discover that TVD, the essential thing, setting and cost and value targets prior to design, right? And then steering towards those targets through design and construction. That started with Henry Ford in the 1910s in manufacturing, and also with Volkswagen. They developed their people car, Volkswagen, in the 1930s using that approach. Value engineering appeared in World War II, driven really by the problem of strategic materials, trying to find alternatives. And then there was even a designing to cost program after the war, actually in the middle and late 50s and into the 60s, that you called designing to cost in the US Department of Defense. But then, and then that culminated, at least thus far, in target costing and lean product development. As, for example, Toyota developing the Lexus program or the Prius program and so on, as I mentioned before. That's all in manufacturing. But then now we move into construction. So in the early 1950s, the quantity surveyors in the United Kingdom developed something called cost planning. And cost planning was a form of target value delivery. And they did it really because they were challenged with reviving schools, hospitals, a variety of public institutional buildings, if you will. And so they needed to better manage cost and value. A similar story happened in 1980 with Finland, the Hattala Group, which I've already mentioned. And they again were driven by the desire to expand their institutional building program. And they had been in the habit of providing subsidies, governmental subsidies, even if they were privately owned. But they didn't have effective ways of controlling cost in those circumstances. So TVD gave them that. And then most recently in the US, lean target value delivery. And I use that because it was influenced by all of these, including target costing and lean product development. Right. So we think that there are many instances that we didn't identify, and it's called forth as a kind of general solution to cost problems, very often rooted in the very depth of societies, right? So, and I think that's kind of where we are now worldwide. Let's see, I have 3.5, let me just see. I think I have a lot more material than I'm going to be able to cover, but let's see. I've included here, this is an old one. I'll just really quickly present this. So this was for Sutter Health, I mentioned before. This was a medical office building. They did this as one of 22 lean projects between their take-up of lean in 2007 and the report to our project production systems laboratory at University of California in 2012. And the success of those 22, all on or under budget, all on time, and all fit for purpose. And that was the testimony of Sutter Health's chief architect. And these shows the differences between the different, between benchmark or market cost, expected cost, target cost, and actual. Okay? Now this is from, this is an interesting one. It's more recent. They began in 2016. If you can see, look at the upper right-hand corner. So this is a series of outpatient facilities for a large Midwest healthcare company, Advocate Aurora Health. And this was this is part of chapter 7.3, I believe. So this is the kind of information you will be able to see in that chapter. And what they did was they set targets, cost targets, based upon what they had been able to achieve previously, set stretch goals, right? And every year they record, well, did we meet those or did we not, right? And their they've always been lower than they've achieved their stretch goals or stretch targets. And what's more, they're doing this. What we don't see here is if we went back from, if you looked at a similar building in 2021 against a similar building in 2016, it would be, the cost would be actually the result of all those percent reductions, right? So it begins to add up hugely. Okay. Very close. I'm just going to answer these, not provide the reasons. Okay, should all projects use TVD? Yes. Can all projects use TVD? Yes. You don't need very sophisticated programs. They help the more complex and difficult the project, but basically TVD is a matter of thinking properly, right? And organizing appropriately to promote the thinking and practice that you need. What's the relationship of TVD to Lean? I think that it's really, I think what we came to see in the research project over from back from 2016 or whenever it was, is that TVD is really a way of delivering projects. It's a project delivery process. And we think that it is not just a project delivery process, but the best project delivery process. We limited the scope of our book to buildings only because there's so much more data available about TVD in the building sector. But we have no reason to think that it isn't equally applicable to all construction sectors. Should all projects set stretch goals? A stretch is a relative term, right? The question is, what risk are you willing to bear, right? And what after you've done everything you can to mitigate, right? And then you're just up to chance, right? So I think, yes, everyone should set stretch goals, but that doesn't mean that you do it arbitrarily. You do it after careful consideration of uncertainties and abilities to mitigate uncertainties. Right? So we are, I think, out of time. When you get the slides, remember to use the notes page view so you see the words beneath the slides. You don't see them here. This is just words on the slides. All right. Okay, I'm not going to, there are interesting recommendations for future research, but I'll leave that to you so that we can get to the discussion. Thank you.